My data viz tips for doing parameterized reporting. I have kind of like 3 categories of tips. But before I even get to the categories, the first thing I want to tell you is that there's no magic package. I think, when I come into something like this, or when people ask me, they're like, okay, there's got to be a package, a single package that I can use that's going to like solve all my problems. Do you need to fix something? Okay. So the first thing that I think you really need to do if you're making data viz and you're going to be, making as you'll see, I make a function for one chart, and then you're going to be making it multiple times, you need to consider the outer limits of your data. What do I mean by that? Here's a chart that we make for Oregon by the numbers. Very simple chart, right? It's looking at median household income in a single county in Oregon, and then it compares that to Oregon as a whole. The data that we work with looks more or less like this. You've got geography, amount, and then amount formatted as a variable that we use to just put the text values on and have them look nice. What we end up doing then, again, is we make a function. So here I have a function for median income plot. And in my function, you can see on line 3, which I've highlighted, we take our median income data and then we filter it to say, only keep whatever county it is that we want to plot, as well as Oregon. And then that gets piped into ggplot. Now, I'm not going to walk through the details of how we actually make the plots, because that would take us far afield from where I want us to go. But just know that there's a bunch more ggplot actually than what I'm showing here. So then, for example, if I make median income plot for Jackson County, which is a county in Southern Oregon, we end up with a plot that looks like this. No problem, right? Looks good. Say we make a plot, we do the same thing for Harney County, a county in Eastern Oregon. Again, looks fine. But then let's say we make a plot for Washington County, which is a county in the Portland metro area.
This is so distracting. I'm sorry. We're really trying our best.
Turn it off and on again.
Oh wait, sorry.
Well, we'll just do it. Fix this at the next break, so you don't have to see the full toolbar. But right now, you have to see it.
Whoa, we pierced the veil. Now we're back. Okay.
All right, so if you take a look at this, hopefully you see the problem, right? Like look at that Oregon bar. In the Jackson and Harney plots, it's all the way to the edge. In the Washington plot, it's not. And like that's going to look weird if you make multiple reports and the size of the Oregon bar is different in the reports. So how do you need to deal with this? Yeah. So to deal with this, what we end up doing is we create a variable called max median income. So we take that median income data. Then we use the slice max function to get just like the top value for median income in any single county, or it could be Oregon. And then we use the pull function to grab that single variable. So then we have a variable, again, max median income. So now when we run our code again, we can just add scale x continuous, and we set our limits to go from 0 all the way up to max median income. So if I do that for Jackson County, you can see how the 76,000 isn't going all the way to the edge. It's just going like 3/4 of the way there, which is great because then when we do it for Harney County and for Washington County, it all lines up and looks good. Next kind of category of tips is to minimize your text and position it carefully. It can be really easy if you're making a single plot to think about like, adding a whole bunch of text labels. If you are making multiple plots, adding a ton of text labels is going to lead to text overlapping or showing up in weird places, making it hard to see your data. So minimize it and then think very carefully about where you actually position your text. The first thing that I suggest is not to try to label everything. So this is an example plot looking at population projections broken down by age group. In this case, it's for Hartford, Connecticut. And so the data that we use for this looks more or less like this. I've made kind of simplified versions of it. So you've got location, year, age group, percent, PCT, and then percent formatted, which again, we use for the text labels. So the function that we make looks more or less like this. Again, start with our population projection data. Then we filter. In this case, we're filtering to keep both a town as well as a county because we're comparing those, and to keep Connecticut. And then we pipe that into ggplot. So if we run population projection plot for Hartford and Hartford County, we end up with that. Now note that I haven't yet added text. So when I add text, initially you might think to do something like this. Well, great, let's just add a geom text and we set label to be equal to percent formatted. Well, if you do that, it's going to be really messy. See, like that's too much text. It's hard to read with the lines and the points and the text overlaps. Not great. A solution that I see some people reach for, and in certain contexts, I think can be a really great solution, is the package ggrepel. So ggrepel, if you've never used it, it takes all your text and ensures that it doesn't overlap with other text. The problem, if I use it here, if I add a geom text repel, is it's better, right? Because it's not overlapping, but it's still just a lot of text, right? It's kind of overwhelming. It's visually overwhelming. So what we do instead is we think, well, this is a report, this is a plot made for a report on Hartford, and there's going to be, a plot just like this for every other town in Connecticut. So what do we really want to highlight? Well, what we really want to highlight is Hartford. So instead of showing all of our data, what we do, as you can see on line 6 here, is for that layer where we add that geom text, we filter to only include, again, in this case, Hartford. And then we add a nudge Y to just put it, as you'll see in a second, directly above the Hartford line. And that allows the reader to see, okay, this is the data for Hartford, for the town they probably care about if they're reading the Hartford report, and it's not overwhelming. And you could do the same thing for Stamford, another town in Connecticut. And that looks pretty good. But take a look at like the 65 plus one or the 40 to 64. See how the text is right on top of the points and the lines? It's a little bit hard to read. So one package that we have used to help with this is called shadow text. I actually don't see this used very much at all. First person I ever saw to use this was John Byrne Murdoch of the Financial Times, who made some COVID plots early in COVID using this package, which I thought were really effective. So with geom shadow text, it basically works the same as geom text, but you can add a background color. So you can see I've added a white background. And now if you look at the text, if you focus on the 65 plus, it's probably the easiest place to see it. You can see how it pops a little bit off of the lines. And so it's just a lot more visible. And so ensuring that you set your text up in a way that it's going to be visible no matter whether it is like in the 20 to 39 where it's just on a white background or it's on top of another line is really important when you're making multiple plots. Another tip is to hide small values. So here is a plot that we made looking at housing cost burden for renters. So this looks at basically what percentage of people's income do they spend on housing. Our data looks more or less like this. We have location, burden level, percent formatted. And again, very similar process where we make that function to make a plot. We're keeping the town we want to plot, the county we want to plot, and again, Connecticut, piping that into ggplot. All right, so say we wanted to make a plot for Hartford and Hartford County. You can see we end up with a stacked bar here. Take a look all the way on the right side. See how the 7%, 6%, and 6%, they're kind of like pushing on the edge of the bar. That doesn't look super great. And especially, I mean, these ones actually aren't as small. Imagine if you have a bar that has like 1%. It's going to look really goofy. So just to show you, here is the data just for Hartford. What we end up thinking is, okay, well, let's not put the text label if our value is below a certain threshold. So in this case, for example, what I do is I say, mutate percent formatted, if else, if percent is greater than 0.07, then keep it as percent formatted, otherwise make it NA. In other words, if the value of percent is greater than 7%, then we'll keep the text, otherwise we're going to drop it. So we end up with with a data frame that looks like this. And if you look at the very bottom, you can see for the not computed, for the percent formatted, it shows up as NA. So here, if we do the same thing now, it no longer shows up, which is going to look much better. And again, if we do this for Stamford County, or Stamford, which is in Fairfield County, you can see it doesn't show up as well, which is ideal. Last text tip is to not put text where it could be obscured. So here, for example, these are kind of pre-post plots looking at knowledge assessment on those child welfare trainings that I was talking about. The data looks more or less like this. You've got whatever question, the timing pre-post, the rating, and then the growth is like the difference between the pre and the post. Growth formatted is just, we add a little plus sign to make it look nice. And then growth text position is basically where we're going to put that growth label. So we calculate that basically right in between 1.6 in this case and 4.2. We have a function to make a pre-post plot. You give it a data frame, and then it pipes that into ggplot. And we end up running it, and it looks like this. Now, again, I haven't added any text. So the way I would add text would be something like this. It would actually be with multiple layers. Say first I want to add like the ratings within the point. So basically like, what's the average rating for the pre and the post? I put that right in the middle in white. Then I want to add those pre-post labels. So it says like, this is the pre point, this is the post point. I do that with another geom text. And then I add that growth label, which I was talking about, which I want to put right in the middle. So when I run this, what I end up with is a chart like this. And this is actually a real example. I made this chart. And one of my consultants, Tanya Shapiro, said to me, hey, David, that looks great for that data. But what happens when your data looks like this? What happens when the pre-rating is 3.5 and the post rating is 3.6? So in other words, there's not really that much growth. Well, our chart looks like that. And that's not what we want. So the way we dealt with this was we thought, well, what if we put the both rating text as well as the kind of pre and post labels to the left of those points and the post to the right? Because we looked at the data, we saw that there was always growth on any single question. And then that would help a lot to make sure that it's never going to overlap in this way. So we do that by saying rating text, we create a new variable called rating text position, which is if it's the pre-data, then we do rating minus 0.2. If it's post, rating plus 0.2. You can see then we have that rating text position. And then we add the geom text with the rating being at rating text position, and same thing with the timing. And so we end up with that. Now we still have that growth label, which is a little problematic because it's right in the middle and it's still overlapping. So what we ended up doing was using a geom label where x equals 6, which just means we put the growth all the way on the right side outside of the plot. Last set of tips is to highlight strategically and importantly. And when you do this, it's important to think about using various aesthetic properties, things like color, size, shadow, outline, and opacity. Just to give you a couple examples, this is a plot that we made looking at the percent of single family homes as a percent of all homes in Connecticut. And so in this case, the large blue line represents the town that we're showing. All the gray lines represent every other town in Connecticut. Our data looks like that, very simple. And then we just make a function, single family homes plot. The only thing that I want to highlight is we use geom point with shape 124, which you probably have never used. I had never used it before this. It just makes the simple up and down line as opposed to the circle that you're probably used to with geom point. So single family homes plot, again, gray lines represent every single town. Then what we do is we add a layer on top of this geom point just for Hartford. We're filtering for Hartford. And we use that color, which is a dark blue. So you can see Hartford there all the way on the left. Now that's good, but it's still a little bit hard to read. So we also use size. So we say for this layer, we want size to be equal to, in this case, 15, and that makes it bigger, which is a lot easier to read. That works for Hartford. If we do it for Stamford, it works as well. All right, last tip is to use shadow. So this is a map that we made looking at, in this case, rubella, the status of rubella in various countries. In this case, you're looking at it for Afghanistan. This is geospatial data. So the section at the top is the kind of metadata, it's simple features data. And the geometry column is also because you're working with geospatial data. Then you've got country, region, status, which I'll talk about in a second. So we make a function called region map. For the first layer, for that geom SF layer, which is working with geospatial data for region 1, that's the region that we're focusing on for this report, we set that the fill to be equal to status. So in other words, if it's not achieved, it'll be one color. If it is achieved, it'll be another color, et cetera. But then we also add this kind of surrounding countries, that's region 0 in the background. So here's our region map. But let me go back to here for a second. What we like to do, if this is for Afghanistan, we want to highlight Afghanistan. We do that with shadow. There's a package called ggrepel, which you can see we're just adding an additional layer here where we're saying GMSF, data, rubella, and then we filter for Afghanistan. But we wrap it in that with shadow. And when you do that, it just gives a little bit of a shadow on Afghanistan, which is really nice. And you can actually, you don't have to use this just with geospatial data. This works with bars, anything you want to use it with. But it would be nice if we could also use an outline to make it pop a little bit more. So for that, I add a line width of 0.8 and a color of white. And there we go. Last thing we do with this is we use opacity. So we don't adjust the opacity of Afghanistan. Instead, we adjust the opacity of the background layers. So that light gray layer was already pretty light, and we added an opacity of 0.5, you can see on line 11. But then we also, for the countries in that region, adjust the opacity a little bit to make them lighter. So now you can see that those countries are lighter, and Afghanistan really pops off the screen. And that works as well for Iraq or any other country you would work with. So in conclusion, consider the outer limits of your data, minimize text, position it carefully, highlight strategically and programmatically with the range of aesthetic properties, and packages are helpers, but you are the one who has to do the thinking. Thank you.